For decades, we thought the double sunset was just something from Star Wars. A desert world with two suns seemed like pure science fiction. When George Lucas imagined Tatooine in 1977, astronomers thought stable binary planets were impossible. They believed the gravity would be too chaotic. It took 34 years for science to catch up to imagination.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
In 2011, NASA's Kepler mission found the real thing. It's called Kepler 16b, a world that orbits not one star, but two. It's known as a circumbinary planet. Its discovery proved that the universe is far more creative and cinematic than our movies. In our solar system, everything orbits a single point. But in a binary system, the two stars perform a constant gravitational dance, orbiting a shared center of mass. This creates a chaotic region close to the stars, a gravitational danger zone. Any planet that forms too close gets slingshot out into deep space by the shifting gravity. To survive, Kepler 16b stays at a safe distance. It orbits just outside this unstable zone in a delicate path that astronomers call the critical stability radius. But Kepler 16b isn't an anomaly. It was just the first. Since its discovery, we found a whole family of these Tatooine worlds. There's Kepler 34b and Kepler 35b, both gas giants. These systems showed us that binary planets can exist around different types of stars, from yellow dwarfs like our Sun to smaller red dwarfs. Then came Kepler 47, a game changer. It's a binary system with not just one, but multiple planets. It proved that you can have entire complex solar systems orbiting a double star. Finding them is an astronomical nightmare. We usually find planets by watching them block their sun's light. But with two stars constantly eclipsing each other, the light signal is a mess. Scientists have to disentangle the dimming caused by the stars crossing each other from the tiny dimming caused by the planet. It requires perfect timing and massive computing power. So what is Kepler 16b actually like? Despite the sci-fi romance, it's not a place for a vacation. It's a cold gas giant, roughly the size of Saturn, made of rock and gas. Its two suns are smaller and cooler than our own. This leaves the planet in a deep freeze, with temperatures plunging to minus 100 degrees Fahrenheit. But what if a rocky planet formed a little closer? Could life exist with two suns? The habitable zone in these systems is tricky. It moves. Because the stars move relative to the planet, the amount of sunlight, or insolation, changes drastically over days and weeks. You'd have chaotic seasons. Astrobiologists suggest that plants on such a world might be black, not green. They would need to absorb every possible wavelength of light from two different colored stars to survive. Imagine standing on the surface. You would cast two shadows. As the orange star sets and the red star rises, your shadow would split, change length, and even change color. The sky itself would be a shifting canvas. Midday might be a mix of yellow and red light, fading into deep crimson twilights that last for hours. This might sound alien, but it's actually normal. About half of all the stars in our Milky Way galaxy are binary pairs. Single stars like our Sun are the lonely exceptions. That means there are likely millions, perhaps billions, of Tatooine worlds out there. Some are gas giants like Kepler 16b, but others must be rocky Earths. We haven't found a habitable one yet, but the search is just beginning. Every time we look at a binary star now, we wonder, is someone looking back? Future missions like the European Space Agency's Plato and Ariel telescopes are launching soon. They will stare at these binary stars, analyzing the atmospheres of their planets, sniffing for signs of water or life. So if you could watch that double sunset, who would you want sitting next to you? The universe is vast, and we are just starting to learn its dance. Let me know in the comments, and don't forget to stay curious.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.